So a couple weeks ago, I was actually playing Pong with my younger brother, and while I was beating him, it got me thinking about how iconic this game really is. I mean, if you were to show this picture to any random person on the street, chances are they're gonna guess where it's from. Because of this popularity, there have been so many cool ways people have been trying to play this game. Whether that's from creating a reinforcement learning algorithm to teach a computer to play the game on its own, or even recreating it in a one-dimensional space with light. What if I told you that we can play this game in a different way? A way where we don't really need a keyboard or controller, because the controller we're going to be using is this. Well, and this, and that. Now I'm sure you're wondering, how on earth are we going to do that? Well, we're going to be doing that by using this. This is a brain-computer interface. A brain-computer interface, or BCI, is a system that interprets brain signals from a person and sends that over to a computer or a machine. The computer or machine will then perform a specific command depending on the types of signals received. Now there are many different ways to do this, but the most common way is a non-invasive method known as electroencephalography, or EEG for short. EEGs are basically a bunch of electrodes that are placed on the scalp of our head or anywhere to read the different electrical signals throughout our body. And there are three main types. The first one is electroencephalograms, or EEGs, which basically measures the brain signals. The second method is known as electrocardiogram, or ECG, which is used to measure the heart data within our body. The final method is electromyography, or EMG, which is used to measure the muscle data. And as you probably guessed, we're going to be using EMGs to detect the muscle movement within our hand. Now this BCI specifically is the OpenBCI's ganglion board, which functions similarly to an Arduino. Each arm consists of 3 different electrodes. 2 placed on the forearm to detect the muscle movement whenever we're flexing, and then the third one on a bony surface like the elbow as a ground electrode to make our measurements more accurate. Okay, so now that we set up everything, how are we actually going to take that data and tell the computer to move the paddle? In order to do this, we have to actually code it out. This part of the code is used to connect the ganglion board to the computer with BrainFlow, which is basically an open source Python library that is used for interpreting data from BCIs. Alright, now once we connected it, we can't just blindly get the program to run and see if we're gonna flex or not, because the computer really doesn't know anything. That's why we also have this calibration process. Once it's done that, it's going to subtract the maximum value from the average value to get the threshold. Now if it does pass this threshold, then the program will then press the up or down arrow key depending on which arm we flex. Even though this seems pretty simple, it took almost 5 hours to actually build this project. But I'm sure you don't really care about this, so let's actually move on to the demo. As you can see in this high quality demo, whenever I flex one of my arms, the program inputs the up arrow key and the paddle is moving up. And when I flex the other arm, you can see that the program detects it and moves down. You would not believe how relieved I was to see this in action. And even though it was just a fun little way to play Pong, it allowed me to dive deeper into this field and set me up for future projects.